Let us look at Euclid's Elements, Book 10, Proposition 30, where we have to figure out two straight lines. Given a straight line AB such that AB square is greater than AC square by BC square, where BC is incommensurable with AB. So here incommensurable basically means that BC and AB can't be measured by the same number. This looks like Pythagorean theorem. AB square is equal to AC square plus BC square. So which means since AB is the given magnitude, we want to create a right angle triangle on it. And we know the best way to do it is by drawing a semicircle on it, so that AB will subtend a right angle on any point on this circumference. So what we do is, first of all, we figure out, or we take two square numbers. So 9 is a square number, 4 is a square number. And we have to take these square numbers such that p square plus q square is not a perfect square, or it is not a square number. So here we have taken 9 and 4. Both are square numbers, but if we add them up, which gives us 13, 13 is not a square number. Now we take the proportion. P square is to p square plus q square is equal to AB square is to AC square. Now remember, this can be written in this way. P square by P square plus Q square is equal to AB square by AC square. And because we have to find AC, because everything else we know, let's rearrange this so that we get AC is equal to square root of AB square times Q square by P square plus Q square. Here AB square and square root get cancelled out, so we take out AB times square root of Q square by P square plus Q square. We have got one side of the right triangle. So let's draw that line. So for that, we draw a circle with center at A and radius as AC. Take the intersection and join AC. Now we just join BC to get the other line. But then for AC, we have a way of figuring out the length. So similarly, we require for BC as well. So let's figure out BC. BC can be found by applying the Pythagoras theorem, because we know AB square is equal to AC square plus BC square. That means BC square is equal to AB square minus AC square. So BC is equal to square root of AB square minus AC square, which can be written as AB square root of AB square minus, we do the substitution for AC. So square of this AB square times the square and the square root will cancel, and we are left with Q square by P square plus Q square. Here AB square is common to both the terms under the square root. We take it out, and since it's a square, we take it out of the square root. So we are left with AB times square root of, now here we have 1 minus Q square by P square plus Q square. Subtract these two quantities, we get P square by P square plus Q square. If we subtract these, so that we get this AB times square root of P square by P square plus Q square. Now here in the denominator, we take out P square common out. So we have p square times 1 plus q square by p square. P square and p square get cancelled out. So we are left with AB times square root of 1 by 1 plus q square by p square. Now, what we'll do is we will say, okay, let k be equal to q by p. Remember, here we have to take it in these square numbers, we have to take it in such a way that p square is greater than q square, or we can say p is greater than q. So finally, we get AB times 1 over square root of 1 plus k square. What do we have? We have got all the three sides. So now we can say AB square is greater than AC square by BC square, where BC square is incommensurable in length with AB square. Now, for this particular case, we will have AB square is equal to AC square plus BC square. Numerically, this will be 6th square is equal to square root of this number 11.07692 square plus square root of 24.923076 and so on square. So here remember, this is AC square, this is BC square. BC square is incommensurable in length with AB square, means we basically ignore the square and see that square root of this is incommensurable with 6. Now here remember, GeoGebra, rounds it off and stops. It may be a valid complete solution, or it might be a rounded off figure. Because if it is an irrational number, the decimal points will keep going on and on and on. So we have found two magnitudes AC and BC such that AB square is greater than AC square by BC square, where BC is incommensurable with AB. So now, whenever we have to find magnitudes satisfying this property, we can immediately take AB as one magnitude, and we can use this formula to arrive at the other. And using Pythagoras theorem, we can figure out the other one. That's it for now. Bye.